Welcome to a video on energy around us. In this video, we'll be looking at potential energy. What is potential energy and the different types of potential energy that we can find? Right, so potential energy is energy that is available but is not being used yet. In other words, it is the potential to do work, and we can see an example of that in these stones that are balancing on top of one another. Right, which is quite frankly amazing, because I'm not sure how this person did this, but kudos. So these stones have a potential to fall over or to topple over back to the ground, but that hasn't happened yet. But because they have the potential to move when they fall, that is basically what is the potential. That's the potential energy in this image. So there are 5 different kinds of potential energies. There's elastic potential, there's gravitational potential, there is magnetic potential, there's also chemical energy, and then there's also nuclear or atomic energy. So we'll start off with elastic potential. This potential for energy is formed every time an elastic material is stretched, compressed, or twisted. So if we look at this image here, we see a spring, and when the spring is static, which means not moving, or if it's at rest, this is its shape. If we compress the spring or stretch it out, we create elastic potential in the elastic material. And once we release our force on the spring, it will move in such a way that it will return to its static or resting shape. And this movement comes from the elastic potential that was created. So elastic potential is then converted into kinetic energy. And the same can be seen with elastic or rubber bands. When we stretch or twist the band, and release it, it will move back to its original shape. And we use this idea to irritate the teachers or to irritate our friends when we're in class. When we're supposed to be listening or working, we will use elastic potential to do all sorts of naughty things. Right, so that also is applied to the bow and arrow. When you pull back on the bowstring, right, which is this part here, the bowstring, you create elastic potential, right? You create that potential energy. When you release the bowstring, it will convert that into kinetic energy, which is then transferred into the arrow, sending the arrow flying forward. And the more force you use to pull the bowstring, right? The more you pull the bowstring back, the more elastic potential you create. And when you release the bowstring, the more kinetic energy will be generated from that elastic potential that you've created. And to do that, to create that elastic potential in bows, especially like in this compound bow over here, you need quite a bit of, you need to have some muscle to generate enough force yourself. So it helps to have that muscle if you want to become an archer and build that elastic potential and release it as kinetic energy. So gravitational potential is the next one we're looking at, and this potential is the potential for energy due to an object's position in a gravitational field. Basically, it affects, or it's potential energy that influences an object within a gravitational field of another object. And objects like stars, planets, and moons will generate gravitational potential because they're large enough to, they have enough mass to. And people usually think of gravitational potential as what keeps our solar system running, what keeps the planets moving around the sun, which is correct, but it also applies on a smaller scale, like with us on Earth. So it doesn't matter where you're standing on this planet, on Earth, you are being pulled towards the center mass of the planet. So the gravitational field is pulling you towards its Earth's center mass. And that's why it doesn't matter where you are on Earth, it always looks like, you have your feet on the ground, right? It's not like someone's standing on their head and another one's on their feet. You're all being pulled towards the center, and every other object's being pulled towards the center of this planet. Gravitational potential is also the reason why we've all lost an ice cream friend, right? When that ice cream falls to the ground and we just look at it all sad, we realize that gravity has kind of messed us up. Gravitational potential also influences objects based on their mass or how heavy they are. So it's the difference between a raindrop, right, falling to the ground versus a asteroid falling to the ground. The asteroid will cause a lot more damage because it will have much more kinetic energy than the raindrop, simply because it had much more mass or was way heavier than the raindrop was. So magnetic potential is the next one we're looking at, and this is the potential for energy that exists within magnetic fields. And we can see that these iron shavings have moved in such a way to basically create or show the shape of the magnet's magnetic field. And metals that are ferromagnetic, like iron in this image, and cobalt and nickel, will be directly influenced by a magnetic field and will move due to that magnetic field. Magnetic fields are also used to generate electrical energy, and we can see that in generators like this large generator used in power stations. So it uses magnetic fields or magnetic potential to create an electric current or to create electrical energy. Magnetic fields can be very strong, and like in this electromagnet we can see here, it can actually lift tons of metal at once. The next one is chemical energy. Chemical energy is the energy stored inside of materials, especially materials that are fuels. And I'm not going to go too much into fuels and chemical energy now, but just know that it's stored inside of them. And when I say inside, I don't mean like if you break open a chocolate bar, you'll see a ball of chemical energy floating there. No, it's actually stored within the atoms, not inside the atoms, rather. It's actually between the atoms of materials that are fuels. And when those bonds between them are broken and made again, and they form new bonds, that's when the chemical energy is released. And we'll go more into that when we look at fuels and combustion. So the last one is nuclear or atomic energy, and this is the energy stored inside of atoms. So when chemical energy is between atoms, atomic energy is inside of atoms. So inside the atom, or how atoms look or what they're made of, are these energy particles that are electrons. It's the ones floating on the outside. Then we have the protons and the neutrons in the middle, right? These form the nucleus. And when this nucleus of an atom is split, or when it hits into another nucleus and fuses together to form a new nucleus, that's when atomic energy or nuclear energy is then released as either heat or light. And when people hear, oh, nuclear energy or, oh, atomic energy, they think, first thought that comes is, oh, nuclear bomb or mass destruction or a city destruction, and death and destruction. But truth is, atomic energy is also the reason why there's life in the universe. Our sun, the energy emitted from our sun is why we are all here on this planet, why life can exist on planet Earth, because the atomic energy that is the energy source of the sun and other stars is released as light and heat, and that made it possible for life to exist on this planet. Right, then we have, we also use nuclear or atomic energy in power stations to generate electricity. So I hope that you never stop learning, right? Always keep learning, and until next time. But if you did, do me a favor, if you did like this video, please drop a like. And if you want to see more in the future, make sure you subscribe. Stay awesome. Till next time.